What mice taught us about dying early and how to avoid it. Because sometimes the key to a longer life comes from a very short one. Mice don't live very long. That's part of what makes them so useful in aging research. Scientists can observe the full arc of a life, from spry youth to frailty and death, in under 3 years. But what happens when that arc gets cut short even more? That's exactly what researchers observed in a recent study involving a protein called Gas6, and what it revealed is as grim as it is promising. In mice genetically engineered to overexpress Gas6, researchers noticed a disturbing pattern: rapid onset of age-related diseases, impaired immune function, cognitive decline, and early death. Not just slightly earlier, dramatically earlier. The mice looked and moved like seniors long before their time. Internally, their systems were misfiring. Blood vessels were stiffer, inflammatory markers higher, brain function dimmer. It was as if someone had stepped on the biological accelerator and torn off the brake pedal. This is where things get interesting and unsettling. Gas6 growth arrest, specific 6, is a naturally occurring protein that plays a role in cell signaling, immune regulation, and vascular homeostasis. It's not inherently bad. In fact, in youth and health, it helps modulate inflammation and clear cellular debris. But as the mouse study shows, too much of it, especially later in life, might act as a molecular saboteur, hijacking the body's repair mechanisms and sending them into overdrive. Or worse, turning them against you. The real twist? Mice without Gas6, genetically modified to suppress it, lived longer and showed less vascular and cognitive damage. Their organs aged more gracefully. Their blood vessels retained flexibility. Their immune systems didn't collapse into overreaction. Scientists believe this may be because Gas6, in aging tissue, acts as a kind of false repair signal, trying to maintain damaged cells that should be cleared, prolonging inflammation instead of resolving it, and subtly pushing the body toward dysfunction. So what does this mean for us, the longer-lived, more complicated mammals? This mouse model offers a mirror, albeit a compressed one. And while mouse biology isn't human biology, the translational value is real, especially because elevated Gas6 levels have been detected in aging humans as well, particularly in individuals with heart disease, diabetes, and cognitive decline. If this protein truly marks a biological wrong turn, then blocking or modulating its action could become a cornerstone of future anti-aging medicine. That's where the hope comes in. If we can understand how Gas6 contributes to systemic aging, we might be able to develop targeted drugs, not broad-spectrum anti-inflammatories, but precise modulators that calm Gas6 pathways without turning off the beneficial ones. It's the difference between pulling the fire alarm in every room versus fixing the faulty wiring in just one. Imagine an injectable or oral therapy that, once you reach your 50s or 60s, helps suppress the overexpression of this protein before it causes real damage. That's not science fiction anymore. Early-stage Gas6 inhibitors are already being explored, both for their potential in autoimmune disease and now, increasingly, in the context of aging and longevity. But of course, this also opens up a black box of ethical questions. What's the line between extending health span and engineering lifespans? Who gets access to these therapies first? What are the risks of manipulating such a central regulatory pathway in a system as delicate as aging? Could suppressing Gas6 have unintended consequences in wound healing, immunity, or even cancer suppression? Mouse lives are short and controllable, human lives are not. Still, the lesson from the mice is undeniable. Aging isn't a smooth downhill. Sometimes it's a biochemical ambush. And if we can identify the molecular signals responsible, like Gas6, and find safe ways to interrupt them, we could potentially extend the window of healthy function before decline sets in. Not to cheat death, but to make the time leading up to it far more livable. So yes, a group of short-lived rodents may have just taught us how, and how not, to age. Their shortened lives are giving us a longer view. Not just of what goes wrong, but how we might finally begin to age on our own terms, with less suffering, more clarity, and maybe, just maybe, a few more good years to spend wisely.